Hi everyone, we are back in the office today and we are going to be looking at developing our corrosion lab. So see we have our positive terminal connected to our copper piece right there, you see Cu, and you see the characteristic color of copper. We are connected to our National Instruments My DAC. We have our alligator crypts for our negative terminal, and that is connected to our computer, and we're controlling it with our Python script here. That's going to allow us to measure our voltage measurements. So let's go ahead and get started. And again, if you're interested in this code, please let me know and we'll go ahead and share this on the video as well. And I could kind of zoom in, but it's going to give us an instantaneous plot. So if we hook up copper with aluminum, we know aluminum has a lower electronegativity. And even though we're in a saltwater solution to mimic seawater, so I put some salt in there, or for the lab, I'll hopefully get some salt or seawater, real seawater from Moonstone Beach. But again, we'll address that when we get there. So I'm going to hook up our negative terminal to here. We're going to put it in solution. If you see any corrosion, we want to kind of basically use our... Actually, we want to make sure that these are not touching. So this is going to be hard to do with a couple of hands. So I'm going to just do this here. Whoops. Make sure that we're attached. All right. So we have our solution, saltwater solution. We have our two terminals. So now we're just going to go ahead and click run on our computer screen here. Actually, let me just do that just right now. Actually, here we go. So we're going to click run, and first we're going to stop this one. We're going to run, and we're going to see the measurements pop up here. And we should expect it to be positive, and it is because we know that copper is much more electronegative, so electrons are going to flow from aluminum to copper, so that should be a positive value. And we're going to get these measurements basically every second, and we can see 0.4895, pretty consistent there. Excellent. Now, if we were to switch aluminum with, for example, brass. So brass is composed of copper and zinc, and this particular alloy is quite heavy on the copper side. So we're going to connect that to the negative terminal. Now, these materials should be very close in electronegativities because it's predominantly copper and some zinc. So we should expect a voltage that is actually very close to zero. So let's go ahead and clear that. Let's run our script again and gather our data. Let's see what we get. Yep, look at that value, 0.056, 0.045, very, very, very small values of voltage. So, excellent, looks pretty good. So this gives, again, a sense of our data set, and that's what we get. Now, what about something that's a little bit more electronegative? We're gonna actually use, this is a tungsten ring. So this tungsten wedding band actually has a very high electronegativity. So we should expect now a higher electronegativity than copper. We should be expecting a negative voltage. So let's hook it up. Let's put it in solution, as we see here. And let's let it equilibrate just a second, and then let's go ahead. Let's run. So now we should be expecting a negative voltage to be read. And what do you know? Negative voltage. We could see the same thing for gold as well, but I'm not going to alligator clamp my gold wedding band or my class ring. That'll be for another video. But we see negative, and there we go. So that's what we're going to do in the lab. So now let's go ahead and move on to our analysis. So see you in the next video. Thanks. Bye.